this is actually what we call an indirect ELISA. You can do a direct ELISA. Okay? Just with the use of secondary antibodies. Yeah, you can. Again, it's one of those things where in practice you can pretty much do anything out there is possible. I've never seen anybody do and I've never done personally anything other than an indirect ELISA. And the reason why we're calling it indirect, whether it's indirect immunofluorescence or it's indirect ELISA, is because our marker is not directly binding to the antigen we're trying to transport. If I see my secondary, right, I see this marker, then I'm seeing it because it's bound to the primary, and it's the primary antibody's responsibility to recognize that antigen. So then let me throw out this question now. With respect to the secondary antibody, what is the antigen for the secondary antibody? Yeah, it's the primary. And the antigen for the primary is the thing you're trying to identify. Yeah, the antigen of experimental interest.
Oh, I was just going to check.
Good, let's do it. Any other ELISA questions? All right, wash that out.
So, going back to the very first lab, what is the difference between a hypothesis and a prediction?
Ooh.
I guess what I thought was a hypothesis is
What is the difference? Hold on a second, just trying to see if I. The question was, what's the difference between a hypothesis and a prediction?
Wouldn't the prediction be what you're trying to answer with them?
Okay. I had Xeroxed a couple of awesome answers to questions that were on the lab quizzes that had to do with the scientific method in nature science lab. So I'll read off those that I have in a second, but it's for the hypothesis theory. What's the difference between a hypothesis and a theory and not a prediction? So let me answer your question first. A prediction is predicting a specific experimental outcome. You have to know what your experiment is going to be in order to come up with a prediction. Okay, when you come up with a hypothesis, you haven't thought of your experiment.
So the hypothesis comes first.
Absolutely.
And then you figure out.
And what comes before a hypothesis? Question. So you ask a question. Why X? X happens because this, and this. That's the hypothesis. A hypothesis is an attempt to answer a question. Right? It's a possible answer to a question. It's not a guess. Okay? At its most primitive, it is an educated guess. All right? But a hypothesis is an explanation of why something happens. That is, it's an explanation to your question. Okay, that has a justification to it. Right? But to test that hypothesis, you have to design an experiment. Right? So I can come up with an answer to a question without ever having thought of the experiment. The prediction is, if my hypothesis is going to be supported, I will get these results. If my hypothesis isn't going to be supported, I will get those results. Okay, kind of with me on that little general bit? All right. So let me just go back to this whole thing. I really, at this point in our time together, this is week 9, right? You should realize a hypothesis is a hell of a lot more than an educated guess, right? That's good enough for K-12. Okay. At this point, a hypothesis could be something that has been around for years and years and years. Lots and lots of experimental evidence could support this hypothesis. So the one that immediately comes to mind is the signal hypothesis. Gunther-Blobel signal hypothesis for how secreted proteins get targeted to the endomembrane system and get out of the cell. This N-terminal signal sequence, SRP, the SRP receptor, translocon,